Hello everyone. As we are approaching the end of this data science project, I want to show you how you can define a function to predict lipophilicity values for any external smile strings. For that, I have made another Google Colab notebook named Predict from Smiles. And what we are gonna do real quick is, like before, install RDKit and PyTorch geometric. Along with that, pandas, we want to import as PD, we want to import torch, and we want to import this from smiles method from torch geometric. So let's go ahead and do that. Now this is again similar stuff. We are defining a device here. If GPU is available, it will use that, else it will just use the CPU. Now if you remember from our previous video, we had this PyTorch _lipo final Google Colab notebook where we used the fine-tuned parameters and eventually trained the model and evaluated it. And in the end, we also, after model training, we also saved the model as model _lipo tune.pth. So we are gonna be using this tuned model for making predictions. So coming back to predict from smiles notebook, what I'm doing here is, so I have already uploaded model _lipo tuned model, and we are gonna be loading this model using torch.load, and this is the path where our model is located here. And of course we wanna give the map location. So map _location equal to device, it ensures that the model is loaded on the appropriate device. So for evaluation, we need to call this eval method, and this is the most important part here. So we are defining a function called predict _lipophilicity, which would take in argument as list of smile strings. So there could be 1, 2, 3 or 4 smile strings as an input. And in here we are just creating an empty list called predictions, in which we will later on add our predictions. So since we have a list of smiles, we will iterate through each smile strings. Now if you remember, again going back to this notebook here, if you remember, we generated graphs for the whole data set. So this was the code for that, and it is pretty much the same code which I am using here. So I am iterating through each smile strings. So the in the first iteration, the first smile string will come in, and from smiles method, which we have imported here of PyTorch geometric, would convert this smile strings into graph. And then we want to convert this integer x or node features into float values. So that's what I'm doing in here. And of course we want to push our data to the device. Now one thing that is different in here is we are adding batch information. So again, if you go back, we have not really added any batch information. Instead, we down here we did the train test split, and then we used a data loader method of PyTorch for generating train loader and test loader, and in that we gave the batch size. So since we are just dealing with single smiles or a couple of smile strings, we just need to provide batch information right here. So g.batch is equal to torch.tensor, and then 0 into g into number of nodes. So this creates a batch tensor indicating that all nodes belong to a single graph. So yeah, this is really important here, because the input for the model also includes the batch information. So we need to provide information here indicating that all the nodes belong to just a single graph. And then we will perform the prediction with torch dot no grad. Basically this means we are disabling gradient calculation, which reduces memory consumption and would speed up the computations during inference. And then predictions would be stored in variable called pred, and this is the model that we have loaded up here. And then we will input all these node features, edge index and edge attributes and badge information, and then we will just grab the prediction items from the prediction. So the numerical value that we'll get using pred dot items. So yeah, that would be appended to this empty list over here, and in the end we will return the predictions. So this is the function for predicting lipophilicity, and then we wanna use this function to know the lipophilicity. So basically, let's just randomly draw some molecules here. In my chem draw here, So what we are gonna do is we are gonna draw some molecules. Let's just draw one highly polar molecule like this, and some highly lipophilic molecule, something like that. Let's just copy the smile strings here for this molecule, copy as smiles, and then on camera I am just creating a list containing two smiles here. So and that variable would be external underscore smiles. So one I have already copied, and second for this hydrocarbon here, let's copy as smiles. So here, so we have a list of smiles for which we want to predict the lipophilicity values containing two smile strings, and I'm storing that as external underscore smiles. So all we need to do is call this predict underscore lipophilicity function and put in this list of smiles. So we want to store these predictions as lipophilicity underscore predictions. So what you can do is just comment this one out and just run this code. But before that, we need to run all these lines of code as well. So after that, let's just run this. And after that, if you just print this one out, you will get the prediction. So this value is for this alcoholic molecule here, and this value is for this hydrocarbon. Now just to make things more clear, what I have done here is I have used a zip method in here, which would zip the smiles and the corresponding lipophilicity values. So let me show you what I mean here. So what I've done here is just copied and pasted this line of code here, and I am printing this as a list. So you can see here, this is basically a tuple, and it has smile strings and the corresponding lipophilicity value. So we want to print both the smiles as well as the corresponding lipophilicity value. So what I have done here is for smiles spread in zip, so I'm zipping these two values, and then I am printing the smile strings and the corresponding predictions. So if you run this here, you can see we have the smile strings and the predicted lipophilicity. So this is just more readable. So yeah, if we compare these two molecules, since this is alcoholic, this would be less lipophilic, and this just has the carbons and hydrogens and no polar groups, so this would be more lipophilic. And I think that's the trend that we have seen here. This one was for the phenolic molecule or alcoholic containing molecule, and this one has a less lipophilicity values, and this one just carbons and hydrogens have more lipophilic values. So this is how you can predict lipophilicity values for external smile strings. Yeah, so let me know if you have any questions in the comments, and that's it for now. I will see you in the next video. Thank you for watching.